Welcome to a deep dive into the fascinating world of large language model agents. Today, we're exploring a critical innovation that's transforming how these agents operate, the ReAct pattern. As LLMs become more integrated into complex systems, ensuring their reliability and transparency is paramount. The ReAct pattern provides an elegant solution, allowing agents to not just act, but to reason about their actions, making their decisions visible and verifiable. Traditional LLM interactions often resemble a black box. You provide an input, and you get an output. For simple tasks, this is sufficient. But when agents need to perform multi-step operations, interact with external environments, or handle unforeseen challenges, a simple input-output mechanism quickly breaks down. How does the agent plan? What went wrong if an error occurs? These questions highlight the need for a more structured and observable process. This is precisely where ReAct, short for Reason and Act, comes into play. It's a prompting pattern designed to guide LLM agents through a thought process that mirrors human problem solving. Instead of directly generating a final answer, a ReAct agent iteratively generates both a reasoning trace, its internal monologue, its plan, and specific actions it intends to take. This dual approach unlocks significant improvements in performance and understanding. Let's break down the reason component first. This part of the agent's output is dedicated to generating a chain of thought. It's where the LLM articulates its understanding of the current situation, identifies the goal, plans the next steps, and anticipates potential outcomes. Think of it as the agent literally thinking aloud, strategizing before making a move. This internal monologue is crucial for complex tasks, allowing the agent to break down problems into manageable sub-goals. Following the reason comes the act. Based on its internal reasoning, the agent then generates a specific action it needs to perform. This action typically involves using a tool. It could be a search engine query, an API call to a database, executing a Python script, or interacting with a web browser. The action is concrete, executable, and designed to gather more information or make progress towards the overall goal. The magic of ReAct lies in its iterative loop: reason, act, and then observe. After generating an action, the agent executes it and then observes the outcome. This observation, whether it's a search result, an API response, or an error message, becomes the new input for the next iteration. The agent then reasons again, taking into account the new information, and decides on the next action. This continuous feedback loop allows for dynamic adaptation and error recovery. One of the most significant benefits of the ReAct pattern is the dramatic improvement in reliability. By explicitly laying out its reasoning, the agent makes its internal state and decision-making process transparent. If an action fails, the reasoning trace allows us, or even the agent itself, to understand it failed and how to adjust. This self-correction capability is vital for agents operating in unpredictable environments. Beyond reliability, ReAct significantly enhances transparency. We no longer have a black box. Instead, we have a window into the agent's cognitive process. Developers and users can read the reasoning trace, understand the agent's intent, and debug its behavior. This visibility builds trust and makes LLM agents more accountable, moving them closer to being truly explainable AI systems. The ACT component naturally integrates with external tools and APIs, transforming LLMs from mere text generators into powerful problem solvers. By providing the LLM with a suite of tools, from web search to specialized calculators or database queries, ReAct agents can extend their capabilities far beyond their internal knowledge base, interacting with the real world in meaningful ways. Consider a simple example. An agent asked to find the current weather in London. A ReAct agent would first, I need to find the weather for London. I should use a weather API or a search engine. Then it would, perhaps making an API call to a weather service. It would the API's response, and finally, again to formulate the answer. For a more complex scenario, imagine an agent tasked with planning a trip. It might, I need flight information, hotel prices, and local attractions for my destination. I should use a flight search tool, a hotel booking API, and a travel guide database. It then on these, iteratively gathering information, updating its plan, and about the best options until the trip is fully planned. The advantages extend beyond reliability and transparency to include adaptability and efficiency. Because the agent continuously reevaluates its state and plans, it can adapt to unexpected changes or new information more effectively. This dynamic planning, coupled with focused tool use, often leads to more efficient task completion compared to agents that attempt to generate a full solution in one go. However, implementing ReAct isn't without its challenges. The increased verbosity of the reasoning trace means higher computational costs per turn. Crafting effective prompts to elicit clear reasoning and precise actions requires careful engineering. There's also the overhead of managing the tools and the observation feedback loop. It's a trade-off between complexity and capability. In conclusion, the ReAct pattern represents a significant leap forward in building robust and intelligent LLM agents. By explicitly integrating reasoning with action, it addresses fundamental issues of reliability and transparency that are critical for deploying AI in real-world applications. As we continue to develop sophisticated agents, ReAct will undoubtedly remain a cornerstone, empowering them to reason, act, and learn with unprecedented clarity and effectiveness.